Okay, we're going to do some problems from the college algebra book 2.7, these absolute values. Some of you are going to be retaking the test and had trouble with these, so I'm going to go through these. If it's an absolute value less than, then it can't go very too big. It'll go over 7 or under -7. So we want to make this, if it's less than, it's in between. If it's less than, it'll be in between. If it's less than, it'll be in between. If it were greater, it would be outside. So none of these have the outside. I'll even do 22, just throw it in. I don't think I assigned it, but we'll do these. Okay, so we're going to say that 2x plus 3 is between 7 and -7. We'll add 3, or subtract 3 from all three sections, so we get -10 is less than 2x, which is less than 4. We divide by 2 to get rid of the 2 on the x. It's a positive 2, so I don't need to flip sign, so I get -5 is less than x, which is less than 2. Solve an equation. Final answer in interval notation. So we want to be between -5, not including -5, up to 2, not including 2. This one, first thing I'll do is subtract 1. So this would be 5, and this would have to be less than or equal to 5. So this has to be between 5 and -5. Subtract 1. Divide by 2. Interval notation. So it goes from -3, including -3, up to 2, including 2. Okay, less than 13. So we got -2x plus 7 has got to be between 13 and -13. So we subtract 7. So that's -20 is less than or equal to -2x plus 7, which is less than or equal to, subtract 7 from that, and that would be 6. Oh, I subtracted 7, so there's no 7 there. Oops, my bad. Then I got to divide by -2. And so dividing by negative flips signs, so I get 10 greater than or equal to x greater than or equal to -3. So this goes from -3 up to 10. The numbers are between -3 and 10. So from -3 to 10, I always have to do these from the left to the right, from the smaller to the larger. I can't do 10 to -3. Okay, here's one where we got to be greater. So x minus 20 has to be greater than -1. This is not a good one because absolute value is always positive, which is always greater than -1. So this is all reals. Everything works in here for x. All reals are capital R with double stamp. Let's say it was +1. It wasn't a sign problem. Let's do +1. So if it was +1, this would have to be more than 1 or less than -1. When it's a greater than, you got 2 of them. You do what's here, x minus 20 has to be greater than plus 1, it can be greater than, or the x minus 20 has to be smaller than negative 1. Okay, that's if that was a plus 1. So we add 20 to both sides, and x has to be greater than, or greater than, just greater than, no equal on that, 21, or x adding 20, x has to be less than 19. So we're dealing from less than 19 or 21 and more, so it would be from negative infinity up to 19, not including 19, union from 21, not including 21, up to infinity. So a greater than will always have two pieces unless this is a negative, and a less than will have in between one piece. So that's 22, a modified 22. Now let's go to 44. Write in interval notation. So this is the numbers 7 or larger than 7. So we're going to go equal to 7 and larger. That's all there is to that. This says the numbers less than 4. So 4 from negative infinity up to 4, not including the 4. All real numbers, that's from negative infinity up to positive infinity, all the real numbers. From negative infinity to 6, in set builder notation, that's this notation. A set whose elements are numbers, such that the numbers are less than, not equal, less than 6 in set. This says the set whose elements are numbers, such that the numbers are greater than 4 in set. This says the set whose elements are numbers, such that the numbers are between negative 3 and 5 and equal to the negative 3 in set. And this one says the set whose elements are numbers, such that the numbers are between and equal negative 4 to 1, or they could satisfy the numbers greater than or equal to 9 to infinity in set. And that's the set builder notation.